Okay, so today exercise we are going to talk about wireless LAN enterprise design. So if you are working as a network engineer, wireless is part of your role. It has a cross functionality being a network engineer, even though they are specific role as a wireless engineer, but most companies hire network engineer to do both network related stuff and also wireless as well. So this is a good skills to have in addition of what you know as a network engineer. So already we know that wireless or most wireless network is an extension of wired network. And then wireless and wired client are on the same LAN and can communicate with each other. That is the flow. They are always on the same LAN and then they can communicate to each other. But the way every company have different style depending on the size of the company. So you can have design template as autonomous design or controller based design or cloud based design. So today we are going to focus on autonomous based design where the company have, and all these are infrastructure mode when it comes to wireless, where you have infrastructure to control your wireless. So for autonomous based design, all intelligence is inside the AP. In other words, what it means is an autonomous AP have all the required intelligence to serve wireless client and to connect to the wired network. So if you look at this one, what you have here are all autonomous APs. If you look at the topology we have here, these are all autonomous AP. And then we connect it to access layer switches. Okay, so you connect it to your access layer switches as you see over here. The connection between them is configured trunk because you can have multiple SSID. Okay, so a company can have multiple SSID. SSID is more about the name for the Wi-Fi. So every company have various SSID in terms of how they want their network to be identified. So SSID simply means service set identifier. So service set identifier, service set identifier is what we call SSID in a way to be the name of the Wi or what we call Wi-Fi name. So you configure VLAN as the protocol to the network, and then you can have your multiple SSID with unique VLAN. So as you can see here, this is an SSID with VLAN 30, SSID with VLAN 20. You can also have a management IP so that you separate that from your data. And in that situation, all APs are going to be managed using this network. And then they will also have their own VLAN to be for the Wi-Fi name. So in terms of wireless, the VLAN is more like the VLAN name is more like the Wi-Fi SSID. So every SSID relate to a VLAN and relate to a specific VLAN ID. So that is the way it's going to be handled. And then you configure each AP individually. So this should be configured individually. So this is good for a small setup. If you have so many APs, that becomes an issue. And then let's say you want the capability that wireless user can roam from one AP to another without losing their connection. So somebody is here and he moved to this AP without losing their connection, and the DHCP assigned to them. So they have DHCP IP address assigned to them. So if that user move from here, this PC move and get to this location and has to be connected to this Wi-Fi, then what happened? There is not a problem, but it means that you have to configure the same SSID and VLAN on all APs. So that information should be on all APs. so that you can enjoy roaming in that context. So that is not really fun for bigger environments. This is one of the limitation you have to know using what autonomous based design. You also need to configure your radio's frequency parameters like the channel you want to use and the transmit power with multiple APs. So all these APs should be configured that way. You also have to configure or figure out which channel and what transmit power to use. And there is so there is not enough or there is not enough overlap, or in a situation where you can prevent multiple overlap or no interference between the APs. So you need to ensure that all APs and other AP, when one AP fails, another AP can take over, so that there is no loss of coverage. And this is not fun if you deal with autonomous process. So as I said, with the bullet points here, all intelligence are on AP, so they have to be managed separately. And then the configuration required is trunk for a simple reason of allowing multiple VLAN to communicate. And then if you want to roam, you need to configure the VLAN you want to use on all SSID, as I have explained already. And that stretch the VLAN issues. Autonomous AP also work as standalone, and we configure them one by one. And the downside of that is there is no central point of management, so it becomes very difficult in terms of policing and radio frequency management. But in a simple terms, you can have a small company where they use autonomous APs, and I'm going to give examples of all those APs as we go further. But then in that situation, you are going to have to manage them one by one, and when there is an issue, you have to deal with them one by one. So that is all about autonomous design. So let's go to the second phase, which is the controller based design. So with this design, we achieve or we overcome all the problems we have under the autonomous system, where if you want roaming, you need to configure it on every you need to configure VLAN and SSID on all APs. When you want a new SSID, you also have to create a new VLAN on all switches. That is not fun. So to overcome that, we go to the control based design. And with this design, you move all functions of AP to a central location, which is the wireless controller. So you move intelligence from the AP to where? To the wireless controller. And that is very, very fun. And this is what you see in most of the industry. Okay, so with wireless network, we have the real-time and management function. So the AP should handle the real-time function, but everything that is not delay sensitive can go to the central location, where we separate the management and the real-time function of the AP. So when it comes to management function like client authentication, security management, we are going to deal with all that. Association and re-association through roaming process, quality of service, all this can be done on your controllers in terms of management function. And then when it comes to real-time function for the APs, in terms of transmission of your 802.11 frames, which we spoke about that already, which are the IEEE standard that we have. So all those things can be done on the AP encryption process and all that. Now these functions are not real time, so we can move from them to a central point like the wireless controller, and then we take away some of the intelligence of the AP, which is why we call them lightweight AP, and we move this intelligence to the wireless. So you can see on this design, the APs are not called autonomous, we call them lightweight AP. I'm going to give examples of all that. and this AP are going to be connected to your access switches, and then you have to know the AP management VLAN. Then you just do your access ports configuration, then you connect to the AP. The AP will now look for the wireless controller to associate itself. So if you look over here, I said the lightweight AP connect to the switch in access mode. And then the wireless controller connects to the core switch, which will be the core switch in a trunk mode, dealing with all the VLAN that you are going to use for your data and management. So that becomes very easy. So if you get a job as a network engineer or a wireless engineer, all this VLAN will be configured on the wireless controller. Maybe if you create a new SSID, and then you have to allow it on the trunk if it's a restricted port or it's a allowed VLAN port. So all these are things that every engineer should understand. And then the protocol that communicates with the wireless and the AP is what we call CAPWAP. Now CAPWAP is CAPWAP is control and provision of wireless access points, and the CAPWAP encapsulates all data between the lightweight AP and the wireless AP. So this in a way connect to the AP with a tunnel protocol, which the tunnel protocol we call it as what? CAPWAP. So this is a hierarchy design. So you have your core layer, distribution layer, your access layer where you connect users like printers, PCs, and then you also connect your APs as well. So you can have some of the switches based on the IDF you are dealing with, having this configuration. So in simple terms, control-based design gives you this capability, but in terms of configuration aspect, how you configure or the protocol you use to configure this, it's not trunk. Autonomous, you use trunk. But with wireless control base, you are going to configure them using the AP management VLAN, which when you start working, you have to know what management are they using for the AP. And it's easy to know. You can verify existing AP, and then you look at the VLAN they are using, and in case you are to install a new AP, you know what VLAN to use. And if you are replacing with another AP, there is nothing you do. All you have to do is to make sure you connect the same AP with the same port with already configured VLAN, and then this AP will then discover the wireless controller on the environment, and then we'll be able to deal with that. So I'm also going to go through the models of wireless controllers we have, and also we go through APs as well as the training go further. But this conversation is just to give you idea about the network setup or the topology setup when it comes to wireless. I've already told you there should be network, and then the wireless become extension of the network. So whatever you have here, whatever is meant for, you create another extension for users to carry their laptop around and be able to sit anywhere and have access to the network. And now we have a lot of Wi-Fi devices. So this is important skills to have, and that is the reason why I'm giving you this training, to be able to be comfortable when it comes to that. So that is for this. And then we'll go to the last aspect, which will be cloud-based design. So we have autonomous design, we have control-based design. So autonomous design is what we spoke about, only APs are involved. Control-based design, we have wireless controller, which is also a model, and then we also are a device or hardware, and then we have APs, and the APs should support the wireless controller. And in most company, you will not have one wireless controller. For redundancy purpose, you might have two, you might have three, you might have four. There are companies where they have wireless controllers meant for remote office, and then they have wireless controller, maybe another one for the data center or the corporate network, and then they will have, let's say, redundancy for all those devices in case of hardware failure. But let's go to the cloud-based design. And with a cloud-based architecture or design setup, you have your cloud. So the controller, which more or less is what will serve for management, as we said, the management function. This is more like the wireless controller and the AP concept. The only difference between the two is, in terms of the wireless controller, it's a hardware, it's a physical device, and then with the cloud, is something that you can install on VMware. Cisco have one that is for Meraki device, which is a cloud-based product. So in that situation, it can be on your on-premises data center, on a VM machine, or whatever the case may be. And then, or it can be with a public cloud where you have that services. But the only thing is, with this design, the APs will not be configured access. It will be configured trunk. That is the only thing in terms of the difference with the deployment, like the cloud base and the wireless controller base. But the whole concept is the same. We move the function to the cloud. Data remains local in the network, and we need to trunk from the switch to the AP. And the controller function is to push into the cloud. Cisco offers this with Meraki, as I've told you. But whenever you power an AP, it automatically connects to the cloud and configure itself with the necessary details. So that is the main idea. So to summarize these concepts, in terms of the architecture design, we have in wireless, we have autonomous base. Every device is going to be APs. And then we have controller and AP, but the AP will be lightweight AP, where you separate the management function from real-time function. So the AP will handle the real-time function, and then the wireless controller will be for the management function, and that is where the intelligence process is taking place. And we are going to go through how to configure all those stuff. So the wireless controller has access to all your radio's frequency information, so it can make decisions for radio's frequency management, security monitoring. You can see so many things, but we are going to have a feel of that. And in terms of configuration requirements, we configure trunk port to connect to the network for wireless controller. And APs, if you have to install a new AP, is just a management VLAN, and you are good to go. The same concept when it comes to cloud, just that this will be a trunk port. So see you again in the next class.